Hey there, welcome to part 3 of my demo of Cisco Software-Defined Access using Zero Touch. We've covered a few things so far, an overview of Cisco DNA Center. We've gone over my lab a little bit to see what I've already had set up. And then we actually used plug and play to onboard a Cisco 9300 switch as well as a Cisco 9800 wireless LAN controller. And just at the end of the second video, we provisioned the switch. So we can see here, we'll just jump back into it. We can see here in our inventory, we can see here that the switch has been provisioned. You can see a domain name has been added. The domain name was one of the settings in under network settings and design that I had. So the switch is provisioned now, and we're now ready to actually use LAN automation to automate the underlay for our fabric. So before I get into the actual LAN automation itself, I'll kind of describe real quickly how it works. There are, again, plenty of guides and demos out there for LAN automation. I'll link to one or two of them in the description below. But essentially what's going to happen is we're going to take our control plane border 1 device, this guy here that we onboarded already, and we're going to use it as a seed device. And what that means in LAN automation is LAN automation will use that as a reference point, and it will use that device to discover any devices that are connected to the seed device or to devices that are connected to the seed device. And what that means is we can go 2 layers deep. So by using this switch as a seed in LAN automation, we will actually automatically discover and onboard this edge switch, this 9300 transit control plane, and this fabric in a box device. So these 3 devices still are in the out of the box factory state, sitting at the auto config prompt. And LAN automation will go ahead and actually find these devices, onboard them, and get them ready for our SD-Access underlay. So how's that going to work? We're going to go right in here and do that right now. So very first thing we're going to do is we're just going to go to Actions, Provision, and into LAN Automation. And LAN Automation gives you a few options here that we're going to go through. So we're going to pick our primary site, which is the question is, where is our seed device? So in our case, we onboarded that seed device to San Jose Building 13, Floor 2. So we're just going to select that. We'll pull this down, and we're actually going to see our control plane border 1, which is our seed device. I'll scroll down a little bit, and we're actually going to tell DNA Center which ports on our seed device to use to discover devices. So I already know what these ports are. If we looked at the diagram again, we can see that they're gig 1021 and 22 and gig 1013 and 14. So we go back in here. I'm going to filter on the port status right now because there's 48 ports in this switch, so there's a mix of up and down. But right now I'm going to just filter on which ports are up. We can see here 13, 14, 21, and 22 are indeed up. So I'm just going to select those ports. Click Done, and come back here. We're back to where we were. And then the next thing that we have to fill out, and the next question we have to answer is, and we can see the ports that I selected right here, is where are the new devices going to be provisioned or onboarded to? Now, it's not necessarily a limitation, but one thing we are kind of limited to, at least initially, is any device that we use or that we discover in a LAN automation job or a LAN automation workflow, we can really only put them in one device or one location initially. We will be able to change those locations. So if you remember, I think in the first video, I mentioned that 2 of the devices will be in San Francisco. But for now, we're just going to we're going to select our San Jose location. We'll do San Jose Building 13, Floor 1, and all the devices will be there initially. And then when we go through to actually provision it, we'll be able to change. Where those devices live. So we selected that floor for a device discovered device location. We do need an IP pool, because what a LAN automation is going to do, it's actually going to configure all of the links on the discovered switches as /31 point-to-points for connectivity, obviously. And it's also going to configure loopback addresses. So this was one of the pools I created before I did my demo or started the demo. So it's going to take IP addresses from this pool to configure the devices with. And you can actually give it 2 different pools, one pool for the links between switches and one pool for, say, loopbacks. But I'm just going to use one pool for now. IS to IS is the default underlay routing protocol when you use LAN automation. It's not the only underlay routing protocol you can use with Cisco Software-Defined Access, but it is for LAN automation. It is currently the default, and it's the only one that can be used for LAN automation. There may be other options in the future for other routing protocols. Again, one of the beauties of Cisco Software-Defined Access is that it's automated and that you don't actually have to jump into the devices to configure or troubleshoot the underlay routing protocol. The underlay is very, very simple. It just provides reachability between fabric devices. So in this case, IS to IS was chosen for a bunch of different reasons. And we're just going to, we're going to give it a password. A password is required for IS to IS to actually work. Now, I did promise at the very beginning in the first video that I wasn't going to talk about multicast, and I'm still not going to talk about multicast. But one thing I will highlight here is when you do LAN automation, you can actually check this box, and what will happen is LAN automation will pre-configure the underlay to support multicast in Fabric. So we can see here what it says: enable underlay native multicast. It'll configure the seed devices as the RP in multicast, and all the configured devices will be subscribers to multicast. So I'm going to check this box. We're not going to go and verify. We're not going to do any multicast in this demo, I promise. However, I will select it just because it is there. Now, the last thing we can do here is we do need to give our devices names, or DNA Center will give names to devices. If we wanted to, we could put any kind of word or prefix here as a device name or as a device prefix, and then it'll append a number to that device. So if I put in here new switch, the devices that will be discovered will be named new switch 1, new switch 2, new switch 3, etc. Another option we can do is actually feed it a CSV file that has our serial numbers, because we know which devices I know which devices I'm going to be onboarding and which devices to expect. So I actually have a CSV file that I already created that has a device name to serial number mapping. That's really all it is, just those two fields, device name and serial number. And LAN automation will look at that file and it'll name the devices appropriately based on the serial number. So I'm just going to go ahead and click choose file. I do have the CSV file already created and sitting on this jump host, and I'm just going to choose it here. And then, of course, the last thing to do is to start the LAN automation process. So that box will disappear, and then in a few seconds, we'll actually go back into the LAN automation status just to show you what's happening. Now, LAN automation does take a little while to run. It takes a few minutes. Again, with LAN automation, here, let me just pull up the status here. I'm just going to give it a second. I'm just going to scroll down and kind of show you what's happening here. So I pulled up our LAN automation status screen. We can see here what's that the process has started, right now it is provisioned the seed. So again, I'm not going to dive too deep into what LAN automation is actually doing to discover the device. It is kind of interesting, and we can cover it in another video. But like I said, I'll put a link to another video that does cover LAN automation that a teammate has done, if you want to know more about how it's working. But essentially, it's configuring a basic configuration on the seed device to allow it to discover the connected devices via plug and play. So if you remember when I talked about plug and play in the second video, the new devices are going to come up as DHCP clients. So they're going to try to get an IP address. They're going to try to reach out to a plug and play server. LAN automation will actually configure the seed device to provide that connectivity back to Cisco DNA Center so that Cisco DNA Center can discover the device. So right now it's already discovered one device. This does take a few minutes, and it's a two-step process. And the reason it's a two-step process is Cisco DNA Center doesn't really know how many devices we're to expect. I didn't tell it, hey, I've got 3 devices ready to be discovered, go find them. I just basically pointed it to the seed device, pointed it to the interfaces to use, and told it to do its thing. So you'll see here as we wait it out, and I might pause the video just to let this complete itself. We'll see here as it discovers devices, it's got 1 in progress right now. Eventually we should see 3 in progress. That'll automatically move to 3 completed once it's completed the initial discovery or the initial LAN automation process. So some other things to highlight here. Again, these are just a summary of what we selected when we did start the LAN automation job. We can see our hostname file that has the CSV serial number to hostname matching. And like I said, eventually we're going to actually see, so there we go. Now we've got 3 devices that are in progress. And over a few minutes, and it's usually about, say, 7 or 8 minutes. It really depends on how your devices are connected and how many devices you actually have. Those 3 will actually move over to the completed state, and then we can stop the job. So I'm going to go ahead and pause the video, and once these 3 move over to completed, I'll keep going. All right, so we can see here now we've got our 3 devices that are showing completed. So that took about 9 minutes, and as I mentioned, the Cisco DNA Center doesn't know how many devices to expect, right? So you basically have to let it run until all the devices that you know are new and connected to the network are under this completed count. If you don't stop this, it'll actually run indefinitely and keep trying to discover and onboard devices. So we've got our 3 devices: our Edge 1 switch, our San Francisco transit control plane, and our fabric in a box. They're showing here is completed. So the next step is to just stop the process. So the stop doesn't take long; it only takes about 2 minutes. And what happens is DNA Center will actually go back down to the devices, the seed device and the new devices, and clean up any extra configuration that it added to the devices to facilitate the onboarding. So I mentioned earlier is it actually, it'll configure the seed device to facilitate VLAN 1 to allow those new devices to get a plug and play address. So it's actually going to go ahead and clean that up. It's going to configure the point-to-point links between the devices and the loopbacks, and clean up the IS-to-IS configuration and all that kind of stuff. So while we're waiting for that, and like I said, that only takes a couple minutes, let me just kind of go back to the topology and show you what will happen. So through LAN Automation, once it's finished, this link here, this link, and this link will all be configured. There's a pair of links on each one. They'll all be configured as /31 point-to-point. So there'll be an IP address on either side of both links on all of these links. It'll be configured for IS-to-IS as the routing protocol, which will use ECMP or equal cost multipathing for load balancing. So we're going to get some efficient use of bandwidth between the devices. It'll actually configure BFD or bidirectional forwarding detection to quickly detect a link down so that it won't try to black hole traffic if you have a link issue. And it's going to configure loopback addresses on all these devices as well. One other thing I'll mention, so that this should have stopped by now. Still waiting. But one other thing I'll mention is an option that is in LAN Automation that was also in Plug and Play that I discussed. If we had a golden image or an iOS XE image marked as a golden image in our software image management under DNA Center, LAN Automation will actually automatically upgrade those new devices. So we can see here it's completed. That means the stop is done. We're done. LAN Automation is finished, and all the devices are cleaned up and configured and onboarded. And we'll jump there in a second. But so if we had, say, iOS XE 17.3.2 marked as a golden image, these devices are already running 17.3.1. I already had that image on them. But if they came out of the box with 17.3.1 or 16.10.2, and 17.3.2 is marked as our golden image, LAN Automation will actually go ahead and upgrade those devices during this process. And the same is true during the PnP process. Now, the one thing that actually that happens with that, obviously, is it will take a little longer because each device has to go through the iOS XE install process and reload. So that adds probably another 15 minutes or so to the LAN Automation or even to the plug and play process. But in this case, I don't have a golden image selected. They're all running 17.3.1, which is what I really wanted. So it didn't take that long. So you can see here the status is completed and we're done. So if we jump back to the inventory page here and I just click refresh, we're now going to see the devices that were onboarded. So these were the first 2 that we brought in with plug and play. And now we've got these 3 devices, Edge 1, Fabric in a Box, San Francisco control plane, that are on board as well. We can see that it gave them an IP address on the loopback 0 from the LAN Automation range, that the IP pool that we gave it at the beginning and that we selected during LAN Automation. We can see here that they're reachable and managed. The site that we assigned to them during LAN Automation is here. We're going to change these sites here in a couple minutes. But initially, you're limited to just one site. And we can see some other information about each device as well. Now, the very first thing I want to do, the next step is to actually provision them. But one thing I do want to do before I provision them is I want to change what type of device they are. And what do I mean by that? So if we look here in our inventory and we just kind of scroll over to the side, we see here Cisco DNA Center is designating the access role to all of these devices. Now, during it, there are other ways to get devices into Cisco DNA Center. We use PnP and LAN Automation in our case. But when you do device discovery or network discovery, DNA Center will actually try to guess what the role of the device is in the network just based on how it's connected to everything else. Now, in our case, because we use LAN Automation, because our network is very flat, it just decided that everything was an access switch. Now, this device role setting doesn't have a major technical piece behind it. It doesn't change much in the config. There are little things on the interfaces that we don't need to talk about right now. But what this will do is it'll determine, the device role will determine in our topology view, whether it's in DNA Center topology view or a fabric topology view, which we'll get into, where the device will sit in the topology. So for these 4 devices, I mentioned we've got CP Border 1, Edge 1, Fabric in a Box, and San Francisco Transit Control Plane. I want to see them in a certain view. When I look at the topology, I want to see them actually looking like this. So to do that, I'm going to change CP Border 1 to a border router in inventory. And we'll see here, it'll confirm this in a second, that it's selected as a border router. And I'm going to change the San Francisco Transit Control Plane to a border router as well. So again, it doesn't change anything technically in the device. Or nothing major anyway, but it does determine where the device sits when you're looking at the topology view in Cisco DNA Center. So I've selected both of those as border routers. So our next step now is to actually provision the devices. And I mentioned before, provisioning does a few things. It'll push those standard network settings. It will push the AAA settings, the DHCP server, DNS server, NTP server, domain name, things like that. And it actually fully brings those devices into DNA Center. So we're going to go ahead and do that now. So I'm going to select these 3 devices. So again, we've already provisioned CP Border 1. We don't need to worry about that. And we're going to provision our WLC after. I just selected 3 devices, go to Actions, go to Provision, and Provision Device. So again, same as the last time, the flow is very similar, except in this case, I'm actually going to change our device location. You can only do this once, and that is a limitation to Cisco DNA Center. But because I brought in these devices with LAN Automation, it does allow you to change the location. If you discover a device and provision it with a location, you cannot change that device once you provision the device. So kind of be careful of that. So we're going to put San Francisco CP in San Francisco. Obviously, we're going to put it on floor 2 and building 1 in San Francisco. Fabric in a Box, we're going to put in San Francisco building 1, floor 1. And for our Edge 1 switch, we're going to leave it where we put it during LAN Automation, which was San Jose building 13, floor 1. I'm just going to go ahead and click Next. Remember when we provisioned the other device, we saw our template being applied. Again, that prep for DA template will be applied to all 3 of our devices. The template doesn't have any variables, but if it did, I could click here for each device and fill in those variable values for those templates. Just click Next. And again, these are the common settings that it will push to the device, and I click Deploy, and we're going to deploy now. So again, we could schedule it for later, or we could look at a configuration preview, and we're not going to do that right now. So it's going to go ahead and it's going to assign all the devices to a site, and then it's going to provision the devices by pushing those settings. Now, the other thing that Cisco DNA Center will do when you provision a device is it will, if it's pushing any AAA settings like your TACACS settings, it will actually create those devices in Cisco ICE as NADs or network access devices. So while we wait for this to provision, we'll go into Cisco ICE and have a look at the screen. So that's under Work Center. So this is ICE 2.7 patch 2. If we go to Work Centers and Network Resources, we're going to see our new devices now in ICE. So that means ICE will actually act as a TACACS server for those devices, as Cisco DNA Center has gone into ICE and created those devices as NADs or network access devices. So that's already done. It's done automatically. I didn't have to go into ICE to do anything like that. Now, I did in ICE have to pre-configure things like TACACS policies and authorization and authentication policies, but that's very out of scope for this video. And if you're running ICE already, which a lot of customers are, you already kind of know what those terms mean. They're not specific to SDA or even DNA Center. So So we go back to DNA Center. The provisioning should be done by now. If we click refresh here, we see our domain names that have been appended to our device names, and our devices are fully provisioned and ready to go. So the next step will be to, again, we're going to do some kind of pre-settings as well, get our wireless automation ready to go, and then we're going to go ahead and create the fabric.